Hi, this is Aaron Jerome with another video at Jerome Electronics, a YouTube channel. Shout out to those who helped me out, mycockpitview.com and Necessary Disorder. Today we're going to be talking about converting any number system to decimal. So we can choose any number system we want. This is part E of the Intro to Number Systems series. You're listening to Beastie Boys, Intergalactic Planetary, and great song. We are going to be needing to use this worksheet. I'll be handing out this worksheet to my students. I've probably stated this before, I'll say it again. If my students can get it early and work ahead of when I present, they actually are demonstrating to themselves that they own these concepts. And so that's why I give worksheets and hope they catch on early and hope they can solve these. On this worksheet, you can see they're going to be converting several different number systems, base 2, base 3, base 7, base 16, all to decimal. Okay, so that's what we'll be working on today. And I guess we'll just get started. So we're going to convert to decimal, that would be base 10, from any other number system. That could be base 8, 10, 7, 2, 3, 16, 27, any other base. We can convert from any base, any number system to decimal using these rules. What are the rules? Well, first of all, you have to decide the new number system. And to start out, what I think I will do is convert the number 84305, which is a base 10 number, to decimal, which is base 10. Now, if this set of rules works in any number system, we should be able to convert a base 10 number to base 10. So let's get on to it. Second step. We're going to set up the column weights for the 2 base system. Now, since this is base 10, the bases in the column weights are going to be 10s, and then we will increment the exponents as we go toward the left with our exponents. So the next column weight is going to be 10 to the first power, and then 10 to the second power, 10 to the third, 10 to the fourth. Now we have 5 digits in the original number, and now we have 5 columns. That's what we need to be able to make this conversion. Then we're going to resolve them to their actual numbers. So 10 to the 0th is 1, 10 to the first power is 10, 10 to the second power is 100, and notice that the exponent is pretty much telling us how many zeros to put on these numbers. So 10 to the third power will be 1,000, 3 zeros. 10 to the fourth power will be 10,000, so 1 with 4 zeros. Next, we're going to do what I call install the from number. We're just going to take the number the 84305, and we're going to put the digits in their respective columns. There they are. The next step is to multiply down. So 10,000 times 8 is 80,000. 1,000 times 4 is 4,000. 100 times 3 is 300. 10 times 0 is nothing. And 1 times 5 is 5. Next step, add across. So we're going to add all these up. Of course, if you add 8,000 to 4,000, or 80,000 to 40,000 to 300 to 0 to 5, you get 84305, which is the number. And there you have it, a decimal number, 84305, converted to a decimal number. Now, kind of boring. So let's try another number in another number system. So we need to decide which number system we're going to use and which number in that system we're going to use. And I think we're going to jump to, I don't know, let's go for base 2, a binary number. And we're going to convert that to base 10. We've done that before in previous videos. But this time we're going to use the rule that works in all number systems. So the next thing we're going to do is set up the column weights for base 2. We're going to need 5 column weights, and the first one will be base 2 to the 0th power. then base 2 to the first power, base 2 to the second, base 2 to the third, base 2 to the fourth power. That's enough. And now we'll resolve them to their actual values. So 2 to the 0th is 1. 2 to the first power is 2. 2 to the second power is 4. Notice they double each time. So 2 to the third power must be 4 doubled, that's 8. And 2 to the fourth power must be 8 doubled, that's 16. Next, we need to install the from number in the column. So all of the digits go into their respective columns. And then we multiply down. 16 times 1 is 16. 8 times 0 is 0. 4 times 1 is 4. And 2 times 1 is 2. And 1 times 0 is 0. Add across. That's the final step. 16 plus 4 is 20, plus 2 more. That's 22. So on your worksheet, that was actually the first answer. And I was, I could have asked you to do it, but I wanted you to pay more attention to the video screen. But the rest of these, you can actually pause the video and try to find the solutions before I show you on the video. So just be aware of that. Let's try another number. Because we got this one. Word. All right. So let's go for let's decide on base 3 number. Now, nobody ever uses base 3, but it does exist. So we might as well just choose a random base like base 3 and see if it still works in base 3. It does. So the number we're going to use is 20120. Remember, the name of the base, in this case 3, is not a number or symbol or value that is used when we actually use the system. So we can only use 1s, 2s, and 0s for base 3. Next thing we're going to do is set up the column weights. We do this the same for, every time. It's the same step. So 3 to the 0th, 3 to the first, 3 to the second, 3 to the third, and 3 to the fourth. Now converting them to their actual weight symbols. So 3 to the 0th is 1. 3 to the first power is 3. 3 times 3 is 9. That's 3 times 2 is 9. And 3 to the third power is 27, and 3 to the fourth power is 81. Next, we're going to install the from number. That's the number we're going to start with and convert from, and then to decimal. There it is. Next step, multiply down. So 81 times 2, that's 162. 27 times 0 is 0. 9 times 1 is 9. 2 times 3 is 6. And 1 times 0 is 0. If we complete the next step, add across, then we get the answer, the conversion to decimal of 177. So 20120 is the same value as 177 in decimal. Cheeto. Let's try another one. This time, let's go with what? Let's go with another odd number system that nobody ever uses. Let's go with base 7. Remember, any base works. Seriously, base 7? Yeah, we got this. So base 7. Next thing we're going to do is set up the column weights. So the bases will all be 7s with exponents incrementing as we go. 7 to the 0th, 7 to the 1th, 7 to the 2th, 7 to the 3rd, and 7 to the 4th. Okay, now resolving them down to their actual values. 7 to the 0th is a 1. 7 to the first power is a 7. 2 7s, 7 times 7, that's 49. And then 3 times 7 happens to be 343. 7 to the, I said 2 times, you know what I mean. 7 to the fourth power happens to be 2401. Okay, next thing we're going to do is install the from number. That just means take each digit, spread it across into its respective column, and now we can multiply down. Multiplying down. 2,401 times 4. That'll be 9,604. 343 times 1. 343. 49 times 3. That's going to be 147. 7 times 5 is 35. 2 times 1 is 2. last step, we're going to add across. So 9604 plus 343 plus 147 plus 35 plus 2 happens to be 10,131. 10,131 happens to be the decimal value of base 7 41352. So you're getting this. Hopefully you've been stopping the video and getting the answers before I do. All right, let's try another one. This time we're going to use the hex system, hexadecimal. We're going to convert a number from hexadecimal, but remember, hexadecimal, it uses digits 0 through 9, and then A, B, C, D, E, and F, so that there are a total of 16 symbols, 0 through 15. Okay, so we might see some letters in our hexadecimal number. For example, this is a hexadecimal number, and it appears to be readable as the word code. But it is truly a hexadecimal number that we can convert. If you're intimidated, hopefully not, bring it. Okay, so next thing, we're going to set up the column weights for the 2 base. That means we're going to go 16 to the 0th, 16 to the first power, 16 to the, but we only need 4 columns this time. So there's 16 to the 0th, 16 to the first power, 16 to the second power, and 16 to the third power. Now we're going to resolve them. 16 to the 0th is 1, 16 to the first power, 16. 16 times 16 happens to be 256, and 16 to the third power is 4096. Next, we're going to install the from number. There it is. But we got an extra step in here if we're doing more symbols than 0 through 9. What we need to do is convert those letters to their decimal value, because we're converting the whole number to its decimal value. So C. C happens to be equal to 12. We're going to trade C out for a 12. D happens to be a 13. We're going to trade D out for 13. And E happens to be a 14, and we're going to trade the E out for a 14. Okay, next thing we're going to do is multiply down. No, I don't have these, I can't do this math in my head. That's why I've got it automated. 49,152. That's 4096 times 12, 49,152. 256 times 0 is 0. 16 times 13, wait for it. Okay, it's 208, and 14 times 1 is 14. All we got to do now is add them up. Add across, and that will result in our decimal number for the hexadecimal number C0DE. 49,374 is equal to the value of hexadecimal C0DE. Baby Sheldon says, bazinga, because we're so awesome. Just a little short video this time. It's not a very difficult concept, so I only gave a few examples, but my students will see more of these examples on the exam view test or the assessment, however I decide to give it. Okay, that's the end of this video. Let's talk about what we'll be learning in the next one, because the next one is another video in this series. So we're going to be talking about, next time, part F, decimal to hexadecimal. This time we did any number system to decimal. Next time it'll be decimal to hexadecimal. And the rules are essentially the same in all number systems. So it could say decimal to hexadecimal. Okay. Thanks for watching. Hopefully you learned from this, and come see me next time, next video. Thank you for watching. Bye-bye.